Hello, this video is a tutorial for how to install and use the super secret lib 5000 Python library. It was made by us, the Captivites, for LEGO Spike Prime robots running version 3 firmware for use in FLL competition. This tutorial will go over the basics, like where to get it, prerequisites before installation, the basics of the functions, like how they work, and then also some examples. So you need two things in order to actually get the library on your bot. The first thing is the library file itself. So that would be under Shen MS Teams in the 3249 Captivites submerged repo. This is our team repo where we put a bunch of our code and also where is it? Robot design presentation and innovation presentation. So the file that you want to get is right here, supersecretlib5000.py. This is the library. You kind of need it if you're going to get the library on your bot. I'm just going to download it. So let's put it there. The next thing that you're going to want is any MicroPython tool that can manipulate the board, that can manipulate the file system on MicroPython boards. We like using MP Remote, so that's what this tutorial uses. Yeah, I'll now show steps for installing that on Linux and also on Windows. It's going to be installing Python, pip, setting up a virtual environment, and then installing MP Remote finally. Okay, so as you can see, we have our virtual environment set up. This little marker, which might be only on Windows. I've only seen it on Windows, not on Linux. Or at least I don't remember seeing it on Linux. This little marker here, it'll show like the thing that you could name to your virtual environment. I named it .venv because it's short for virtual environment. Also, by the way, I am currently on Windows, but these instructions that I'm about to show should work on both Windows and Linux. So yeah. All right. Let's just make sure we got MP remote actually. Let's just make sure MP remote is actually working. So MP remote, that starts up a shell. You can see it is actually started. Yep. Okay. This symbol here, that COM10, that is the port that your bot is connected to on your computer. On Windows, it'll be a serial port, so COM some number. And on Linux, I believe it's something like TTY ACM and then a number for a serial port. Okay, so we got that working. Oh, we confirmed it's working. Let's exit out of that. Now let's see what the file system looks like on this. So there's gonna be np remote ls to do like list. Okay, this is the root directory of the bot. That is where we're going to be installing super secret lib5000 and another file that'll help with some efficiency. Okay, so first thing we're going to do is put the library on this. It's going to be np remote copy, and well, probably just put the so it's going to be np remote copy, then put the directory that the library file is stored. Now I directly I cloned the repo, so it's going to be in wherever I put those. So it's going to be projects, and then 3249. That is the repo name, and then super secret lib5000. This will be different for you if you installed it in a different area, but this is where I installed it, so that's where I'm putting it. Well, that's where I'm installing it from. And then this is a symbol for the root directory this symbol for the root directory of the bot. Okay, so it's going to install. We now have the library on our bot, and you can start start using it if you want at this point. But I'm going to add another file on there that'll help with some efficiency when setting up code. I'm going to do np remote edit, so we're going to make a new file because it's not already on the bot. It's going to be called init.json. Now in here, we are going to put some information about the bot, like I don't know. I don't know if you've ever used JSON before, but this will basically be like basic syntax. Okay, so we're going to do a list that is called ports. We're going to put all the ports on the bot in here. Now, you don't actually need to do whatever like hub.port. You don't actually need to do that. You can just do numbers because that's what it is behind the scenes. So you can do like 0 for port A, like up until 5 for F. So like 1, 2, 3, 4, 5. This would be if I can get over there. A, B, C, D, E, and F. So that's not how we have our bot set up. We have it set up in a different way. So you can just put your ports in there. It's going to be, drive, like your left drivetrain motor, your right drivetrain motor, whatever you want to put as your first attachment motor and your second attachment motor. That's going to be left and right attachment motors, and then left sensor, right sensor. If you don't have them set up that way, I don't know, like find it in order. But it's going to be like that, so that's how you're going to access them in your code. So I'm going to set up mine right now. It's going to be XBFR's C, what was it, C, F, B, D, A, and then E. That is how we have ours set up. So that's going to be the form of them. Okay, so that's going to be like, port C, port E. Oh, it's going to be port C, port F, port B, port D, port A, port E. So drivetrain left, drivetrain right, attachment left, attachment right, sensor left, sensor right. And now we can do that to close the list. We're going to make a new thing that is going to be called wheel info. I'm going to do that. Wheel info is going to be a dictionary. Then we're going to put our wheel diameter. This is like your drivetrain wheels, the things that your bot moves on. So that's going to be your diameter. That's going to be the diameter of in centimeters. Ours is 6.1, I believe. And then it's going to be the turn radius. We can type that. And so this is the radius that your bot is turning. Well, this is the tank turn radius. So basically just the spacing in between the wheels, and then that's going to be half of that. So if you're if you were 10 centimeters between each wheel on your bot, you put 5 in here. And actually that is the spacing of the wheels on our bot. So we're going to do that. I messed something up there. There we go. Okay, that is going to be that. This is some very basic JSON, but this is what we're using for the config. Remember this is, that's in centimeters, and that's in centimeters. There's more documentation about that on the GitHub, so you can look there if you need any help. It's the same page that we showed earlier. You just got to go to the wiki part at the top of the page. Okay, so we're gonna save this. It's gonna go on the bot. Oh, by the way, I'm using Vim here. You can use this in any other editor. I'm pretty sure the default on Linux is going to be Nano, and then also I think maybe Notepad. Maybe, I don't know. It'll just go in any editor. Like you just edit this. It's a file. It goes into a file on your drive and it deletes itself. So you don't need to worry about space. So that's going to do that. And now if we do mpurmo ls. You can see if we have that. That's the library file, and then also init.json. Now the way you would use init.json is okay. So I am in the Spike app right now in order to demonstrate the thing that I just showed. This is just an example program that I whipped up in like 2 seconds. It's got like the basic library functions here. No, I'll be explaining those later after this segment. So, yeah. The way that you would use the init.json file is with this library function, init, which basically it creates a configuration on the bot every single time you load your program. It's a temporary config, so it doesn't actually do anything. It's just in the code. Yeah, so the way you'd normally use it is it's all keyword arguments. So it's drive L equals port.a. If I can type there. Oh, I forgot to import the thing that you need for that. 1 second. Import port. There we go. And this drive L equals port.b, and so on. Eventually, there's 2 arguments that you can pass, which are they're all uppercase because they're meant to be constants. Wheel diameter. There we go. It's going to be same as what I showed you in the JSON file. It's in centimeters, whatever the diameter of your wheels are, and then the spacing of the wheels, and then half of the spacing of the wheels. Turn radius equals 5. Yeah, like that. That's a lot to type when you're making a whole new program. And this is stuff that doesn't usually change a whole lot. So that is where the init.json file comes in. You can, we made a part of the init function that basically you can just use JSON equals true, and it'll load the JSON file as if it was the config that you typed. So you don't have to type it 100 times over when you're making your programs. I just thought it would be a good quality of life feature to add, and it ended up being really useful. So yeah.